You ever tried to wrap your head around cryptocurrency and just felt totally lost? Like you're trying to read a different language? Well, what if I told you that understanding the whole thing is actually as simple as brewing a great cup of tea? In this explainer, we're going to demystify the blockchain one step at a time.
Yeah, forget all the complex code and the super technical jargon. For the next few minutes, our guide is going to be this humble cup of tea and the community tea house where it's brewed. Trust me, this simple metaphor is the key to unlocking how this entire revolutionary technology really works.
All right, so to really get why this tea house idea was so revolutionary, we first need to take a look at the problem it was built to solve. And that story starts with the old way of doing things, the corporate tea factory.
For decades, we've all relied on these big, centralized systems, kind of like this corporate factory. You've got a boss, you've got guards, a single authority that you have to trust with your money and all your transactions. But way back in the 80s, a group of visionaries called cypherpunks dreamed of something totally different, a community tea house, where everyone could verify the orders together, using the power of mathematics instead of managers. No boss, just shared, verifiable trust. That dream, though, it stayed just a dream for a long, long time. Until 2008, when this mysterious figure, or maybe a group, known as Satoshi Nakamoto, published a master recipe that was about to change everything. It was a brilliant solution to a really fundamental problem with digital money.
So, the big issue was what's called the double spending problem. In our tea house, we'll call it the double sip, right? How do you stop someone from using the same digital free tea ticket more than once? Satoshi's genius was combining a few existing ingredients, things like hashing, public keys, and a decentralized ledger, to create the very first blockchain. It's basically a public record of every single transaction that everyone can see, and more importantly, that everyone can trust.
Okay, so let's get into the nitty-gritty. How does an order for a digital tea actually get made? We're going to walk you through the entire process, right from the moment you place your order to that perfect cup showing up. And guess what? This is exactly how a crypto transaction works.
First things first, you need a way to securely place your order. Your public key is like your public mailbox address. Anyone can send teas to it, but only you have the private key, which is like your secret, one-of-a-kind wax stamp. You use that stamp to sign or authorize your order. It proves it really came from you, all without ever revealing your secret. Pretty clever.
Now, to keep every order secure, it's put through something called a cryptographic hash function. Just think of it as an irreversible tea blender. It takes any order data, big or small, and grinds it down into a unique, fixed-size digital fingerprint. And here's the crucial part. You can never unblend that powder to figure out what the original tea leaves were. So the whole journey of your tea order, which sounds so complex, really just boils down to these 4 simple steps. First, you shout the order. Then, it waits on the ticket rail. After that, it gets brewed in a batch. And finally, it's sent out on the delivery truck. Let's break each one down.
Step 1. Shouting your order. See, in our decentralized tea house, there's no manager to take your ticket. Instead, you broadcast your signed order to a few people nearby, and they tell their neighbors, and so on and so on. Through this gossip protocol, your order basically spreads like a rumor across the entire network in just a few seconds.
Next up, your order lands on the ticket rail, or what's technically called the Mempool. You could think of this as a temporary waiting room for all the unconfirmed orders. Now, because space in the next batch of tea is limited, the baristas, well, they're going to prioritize the orders that have the highest tip or transaction fee attached to them.
Step 3 is where the real action is, brewing the batch. This is where the miners, or our baristas, come in. They grab a whole bunch of orders from that ticket rail and start racing to solve a really complex cryptographic puzzle. The very first barista to solve it gets to seal the batch, show it to the rest of the network, and collect all those tips as their reward.
And finally, we're at step 4, the sealed delivery truck. Once that puzzle is solved, the new batch or block is loaded onto the truck and it's literally chained to all the previous deliveries. This is the blockchain. As more and more blocks get added behind it, your transaction achieves what's called finality, which makes it practically impossible to ever reverse or mess with. Your tea is officially on its way.
So as you can imagine, our little community tea house got wildly popular. I mean, who wouldn't want to go there? But with all that success came a brand new challenge. How does it handle thousands of new customers and new types of tea without just grinding to a complete halt? Well, one of the key innovations was changing how the staff agrees on which orders are valid. The original method, proof of work, which Bitcoin still uses, relies on a massive amount of computing power and energy. The newer method, proof of stake, used by networks like Ethereum, is way more efficient. It relies on baristas locking up their own money as a kind of security deposit.
Here's an easy way to picture it. Think of proof of work like baristas having to prove their effort by solving a ridiculously hard Sudoku puzzle. With proof of stake, they do something different. They put a security deposit in a glass jar. If they lie or mess up an order, the whole network gets to smash the jar and they lose their money. It's a great way to align everyone's incentives.
The next huge leap was moving away from what's called a monolithic design. You know, where one chaotic barista tries to do everything all at once? Modern blockchains use a modular stack, which is much more like a smooth assembly line. You have specialized layers handling different jobs. One takes the orders, another processes the payments, and a third stores the recipe. This got rid of bottlenecks and allowed things to scale up, big time.
And this new modular approach allows for some amazing new features, like shared security. So instead of a brand new tea house spending years trying to hire a trustworthy staff, it can now just borrow the bouncer or the validators from a massive established network like Ethereum. And what that means is new projects can launch with top-tier, world-class security from day one.
For a long time, you see different blockchains were like these separate digital islands that couldn't communicate with each other. But now, with things like cross-chain protocols, the system has become almost invisible. You can just say what you want. I want a tea from Tokyo delivered to my friend in New York, and the underlying tech just handles it, instantly. It's making Web3 feel as intuitive as Web 2.
And what about the future? I mean, the really, really far-out future threats like quantum computers. Well, the tea house is already being prepared for that ultimate security test. As this new kind of computing gets closer, protocol upgrades are already integrating what are called post-quantum signature algorithms. This makes sure that this new global financial stack stays immune to any future mathematical attacks. The vault is, for all intents and purposes, unbreakable. So, with all this incredible technology we've talked about, modular layers, shared security, these quantum-ready vaults, what does it all actually mean for you, the person who just wants to enjoy a simple, perfect cup of tea?
Well, the answer is that the perfect cup is invisible. The true success of this technology isn't measured by how complex it is, but by its ability to work seamlessly, entirely behind the scenes. It's all about powering a future where you have total sovereign control over your digital life, without ever needing to see the gears turning.
You know, from a tiny cypherpunk ideal to a piece of global financial infrastructure, the journey has been absolutely incredible. But really, it's just getting started. So the real question is, now that you understand the recipe, what new and amazing things will you build with it?
This explainer was brought to you with insights from BAS Research Intelligence. Thanks for tuning in.